Hi everyone. Okay, we're back. We're on this lesson, the intersection of three planes. And yesterday we learned how to do find the point of intersection using matrices. We did questions A and B, and now we're back on this lesson, and we're going to look at example C now. Okay, so we're looking to find intersection of three planes. If you remember the sheet that we filled in, we analyze the normals first to narrow down our possibilities so that we know what we're looking for, and then we find if there's a solution or not. So the first thing we're going to do is analyze the normals. So I do see scalar multiples here. First I'm going to compare plane 2 and plane 1. So I see that n2 is equal to 2n1. So now I want to compare the normals, and I want to see if d2 is equal to 2d1. So here is d1 and here's d2, and I can see that that's not true. So that means pi 1 and pi 2 are parallel and distinct. So we already know there's not going to be an intersection of all three planes because two of them never meet. But we want to know the geometric arrangement as well. So I'm going to look at pi 1 and pi 3 now, because I see that n3 is 3n1. So now I'm going to see if d3 is 3d1. So d3 is -4, and d1, this is d3, is -2, so this is also not true. So pi 1 does not equal pi 3 either. And we could also look at pi 2 and pi 3, and again, they are not going to be scalar multiples either. So in this case, we have no intersection, but our geometrical arrangement is that all three planes are parallel and distinct. So that's going to look like this picture here, where we have our three planes that are all parallel and distinct. So this one has no intersection or no solution, but we are going to, again, show what the solution looks like in 3 space. Okay, so that one was pretty straightforward. All right, so now we're on to D, and we're going to start again with analyzing the normals. Careful here, there's no z, so that means the coefficient of z is 0. So those are my three normals, and I can see right away that there's no scalar multiples. So I'm going to check and see if the normals are coplanar. So n1 dot n2 cross n3 equals. So I want to cross n2 and n3. So that's going to give me 0 minus 28, 14 minus 0, and 6 minus -1, which is 7. Then I'm going to do the dot product, so I get -28 plus 14 plus 14 again, which is 0. So that means if I look at my sheet here and the normals are coplanar, it's either going to be this line of intersection, this star arrangement, or the triangle with no intersection. And we have to use a matrix to tell which one it is. So therefore, LOI, or no intersection. So we are going to enter our values into our augmented matrix. So coefficients of x go first, coefficients of y go second column, coefficients of z, again, be careful, so 2, 14, 0, and then our equal sign, and then we have to move our constants over, so -2, +6, -5, in an augmented matrix. So again, we're still trying to get this L shape of zeros. This is the first 0 we want to get. So we want to make that 0. So we have our choice of what to do because there's a 1 in row 1 and a 1 in row 3. So I'm going to do row 2 minus 3 row 1s. Here's row 1 staying the same. And row 3 is going to stay the same for now. So that's going to give me 3 minus 3, which is 0, -1 minus 3, which is -4, 14 minus 6, which is 8, and 6 plus 6, which is 12. And the second thing we want to do is get a 0 in this position. And we can do that by doing row 3 minus row 1. And we're going to leave row 2 and row 1 the same. And then I get 1 minus 1 is 0, 2 minus 1 is 1, 0 minus 2 is -2, and -5 minus -2 is -3. All right. We don't have to, but I'm going, this 4, 8, and 12, I know I can divide row 2 by 4, so I'm going to do that just because it looks too inviting not to. You don't have to. You can simplify later as well. Actually, I'll divide by -4. So that's going to give me 0, 1, -2, and -3. And now I'm going to go ahead and get my 0 here. And I can only use row 1 and row 2 for that. Or sorry, row 2 and row 3 for that, because if I use row 1, I'm going to get rid of the 0 that I already have there. So I can only use row 2 and row 3, so I'm going to do row 3 minus row 2. And if I do that, 0 minus 0 is 0, 1 minus 1 is 0, -2 minus -2 is 0, and -3 minus -3 is 0. What that row of zeros tells you is that there is a line of intersection, because you can take this third step to mean that 0z equals 0, which is always a true statement. So this is where we let z equal t, and now we have the z parametric of our line of intersection. Okay, so we now know there's a line of intersection, we just have to find it. So 0z equals 0, always true, so we're going to let z equal t. Now we're going to read the y parametric next. So we've got that y minus 2z equals -3, or that y equals -3 plus 2t. So there's our y parametric. And we used back substitution there. We're going to do the same thing with row 1, but it's going to take a few more steps. So row 1 says that x plus y plus 2z equals -2. But we have y in terms of t, and we have z in terms of t. So now I'm going to substitute there. So x plus, so I'm going to replace y with -3 plus 2t plus 2, and I'm going to replace z with t equals -2. So x minus 3 plus 2t plus 2t equals -2. X minus 3 plus 4t equals -2. Add 3 to both sides and subtract 4t on both sides, and you'll get x is 1 minus 4t. So there's your x parametric. So there we've got our x, y, and z parametrics. From that we can get a direction vector. So finding our direction, it's going to be the vector with the numbers that are in front of the t. So -4, +2, 1. And I could take that as my direction vector, or I can take a scalar multiple if I want and have my first number be positive by just multiplying everything by -1. And then I also have to get a point on my line of intersection so I can get it in vector form. So my point is going to be 1, -3, 0. So then we can do, therefore, LOI is R equals 1, -3, 0 plus T 4, -2, -1. And so this row of zeros here told us that we in fact had a line of intersection. And we'll see later on what happens if we instead have the no intersection case for this one. So this is what we got. So I'm going to cut it out and tape it on. Sorry, I'm looking for my pictures. I can't find them. Oh, here they are. Okay, so this is the one we've got here. And I can tape that on. So my 3 planes intersect in a line of intersection where the normals are coplanar. And the line of intersection is along here. Okay. All right, moving on to E. So again, start off with analyzing your normals. Okay, and I can see that N3 is equal to 2N1. So I'm now going to check if D3 is equal to 2D1. So here's D3 and here's D1. -5 is not equal to 2 times -9. So therefore, pi1 and pi3 are parallel and distinct, which means they never meet. So there can't be an intersection of all 3 planes. But since the normal for this is not a scalar multiple of N1 and N3, we have this arrangement. Where we have 2 planes that are parallel and one that intersects each of them at a separate line of intersection, but there's no intersection of all 3 planes, and that's what they are asking us. So our therefore statement is going to be therefore there's no intersection. So in this case, this could be like pi1 and pi3, and this is pi2, but there's no intersection of all 3, so therefore no intersection. So we did all that just using normal analysis and analyzing our D values. We didn't have to use the matrix at all for that one. All right, F. So we'll start off by analyzing the normals. So I don't see any scalar multiples. So we're going to see if they're coplanar or not. So checking, I'm going to do N2 cross N3 now. So -6 minus 2 is -8. 2 minus -2 is 4. 2 minus 3 is -1. Use the dot product. -16 plus 4 plus 1 equals -12. So therefore, we know that we have a point of intersection. All right, so then we use our matrices to find that point of intersection. So we're going to enter our system, our three planes into the matrix. So first column is the coefficients of x. Second column is the coefficients of y. Third column is the coefficients of z. Be careful of negative signs. And the bar represents equal signs, and then we have to move our constants over, which will change their signs. So here's our augmented matrix. And the first thing we want to do is get a 0 in this location. So the easiest way I see to do that is to do row 2 minus row 1. And if you do that, you're going to get 1 minus 1 is 0. Sorry, I'm going to keep the other rows the same. So 1 minus 1 is, sorry, this is row 2 minus row 3, my bad. 1 minus 1 is 0, 1 minus 1 is 0, 3 minus 2 is 1, 1 minus -2 is 3, and 10 minus -1 is 11. And the next thing we want to do is get a 0 in this position. We're making that L of zeros. And I can see that I'm going to do 2 row 3s minus row 1 in order to get a 0 there. So 2 row 3s, 2 minus 2 is 0. 4 minus 1 is 3. -4 minus -1 is -3. -2 minus 1 is -3. And then it looks inviting to divide row 3 by 3. So I'm going to do that. So we get 0, 1, -1, -1. And then we want to get a 0 here. And we can only use row 2 and row 3 because otherwise we would undo this 0 if we bring row 1 into it. So we've got row 1, row 2, and row 3. And we have to get, to get our 0 here, we're going to do row 3 minus row 2. So 1 minus 1, negative 1 minus 3, negative 1 minus 11 is negative 12. And now we've got our L shape of zeros, and we can read the matrix from bottom to top. So the bottom row tells us that negative 4z equals negative 12. So we know that z is positive 3. And then we're going to back substitute. So our second line tells us that y plus 3z equals 11, but we know z is 3. So that's going to be y equals 2. And then we can use our first row to get x. So it says that 2x plus y minus z equals 1. 2x plus 2, because y is 2, minus 3, because z is 3, equals 1. 2x minus 1 equals 1. Add 1 to both sides, so 2x is 2, and x turns out to be 1. So therefore, the point of intersection, POI, is 1, 2, 3. X, Y, Z. Make sure you always follow the proper order. And then we know what that one looks like. And normals are not coplanar. Okay. G. So again, we're going to analyze the normals first. Okay, and they don't look like scalar multiples to me at all, so we're going to find whether or not the normals are coplanar. So 1, negative 1, 4, dotted with, so n2, crossed with n3. It's going to give us 9 minus negative 1, which is 10. 5 minus 27, which is negative 22. And negative 3 minus 5, which is negative 8. So then we get 10 plus 22 minus 32, which is 0. So therefore we either have the line of intersection, like where's my sheet? We either have this line of intersection here, like the star, or we have the triangle. So the triangle is no intersection. And again, the matrix will determine which one we have. So we enter our coefficients of x into the first column, coefficients of y into the second column, coefficients of z into the third column, line representing the equal sign, and then our constants. And the first thing we want to do is to get a 0 in this position here. And I see that I can do that by doing row 2 minus 3 row 1s and keeping row 1 and row 3 the same for now. And then, so row 2 minus 3 row 1s gives me 0 there. 1 plus 3 is 4. 1 minus 12 is negative 11. Negative 2 minus 15 is negative 17. And then I want to get a 0 here. So for that one, I'm going to do move this up so you can see. Row 3 minus 5 row 1s. And leave row 1 and row 2 the same. So that's going to be 5 minus 5 is 0, negative 1 plus 5 is 4, 9 minus 20 is negative 11, and 1 minus 25 is negative 24. And now I want to get a 0 here. So, and I can only use row 2 and row 3 to do it because otherwise I would undo that 0. So I'm going to leave row 1 alone and row 2 alone, and then do row 3 minus row 2. So 0 minus 0 is 0, 4 minus 4 is 0, negative 11 minus negative 11 is 0, negative 24 minus negative 17 is negative 7. So this says that 0 times z is equal to negative 7, which is never true. There's no number you can put in for z that would make this true because multiplying by 0 always gives you 0. And that's how you know there's no intersection, and it must be the triangle arrangement. So we don't have to do any back substituting or anything when the matrix tells us that there's no intersection like that. We just have to find our picture here because it does ask for the geometric arrangement of the planes. So in this case, the normals are coplanar, but there's no intersection of all 3 planes. And so that's what it looks like. I'll just show you there. Triangle analysis will show you my model again. So you can see the normals are all coplanar, but there's no places where all 3 planes intersect. They intersect in these 2 intersect here, these 2 intersect here, and those 2 intersect there. But there's no place where all 3 of them intersect. So that would be a no intersection answer. And then question 2 says, for what value of k will the following set of planes intersect at a line? So this question looks a little different because we can see that our constants are all 0. Okay, so we at least know that all these planes have the point 0, 0, 0 in common. But we want to know where they intersect in a line. And we can see, so our normal for the first, or n1 is 1, negative 2, negative 1. And for n2, it's 1, 9, negative 5. And for n3, it's k, negative 1, 1. So they don't look like scalar multiples at all. And to intersect at a line then, we're looking at them having this relationship, which means that the normals would have to be coplanar. And it doesn't matter which one of these we dot and which 2 we cross. So the one with k, I'm going to pick that to dot, so I'm going to do n3 dotted with n1 cross n2, because I'd rather not cross with a k. And then we can cross n1 and n2. So I'd get 10 minus negative 9, which is 19. Negative 1 minus negative 5, which is 4. Negative 1, yeah, plus 5, which is 4. And then 9 minus negative 2, which is 11. And we know that this has to equal 0, but the normals have to be coplanar. So I can replace this with 0 and then do my dot product. So 19k minus 4 plus 11 equals 0. So 0 is equal to 19k plus 7. So k is equal to 7 over 19. So therefore, when k is equal to 7 over 19, the three planes intersect in a line. So that's the end of this lesson. So what I would like you to do now is go back to the practice from yesterday and finish all of question 2, and then check your solutions online. So you're finish question 2, I think it was B2, B to G or B to H, I'm not sure, but finish all the questions in number 2 and check your solutions.